So first thing we're going to do is look at some graphs and just kind of see what's going on with them. Now, this first one is total revenue generated by arcades and computer correlated with computer science doctorates awarded in the U.S. Now you can see that these are very similar, and so they probably have a very strong correlation. So if you look at this, it's a 98.51% correlation. So that's a pretty good correlation there between number of degrees and the computer science or total revenue by arcades. Okay, now if we look at this one, this is per capita consumption of mozzarella cheese and civil engineering doctorates awarded. So these, they're okay, but they're not really any real relationship with them, but they do kind of correspond together there. And here, per capita consumption of chicken correlating with total U.S. crude oil imports. So how many barrels of oil and how much chicken is consumed. Probably doesn't have a real good relationship there, but you can see the points are kind of weirdly together. Then if you look at this last one, it's math doctorates awarded and uranium stored in U.S. nuclear power plants. So this, again, has a 95.23%. So these they kind of look like they go together, but very odd combinations here is what we're looking at. Different combinations, different values together that not necessarily go together. Okay, so we're going to look at the difference between correlation and causation. Correlation indicates a relationship between two variables. Thus, the correlation coefficient tells you if there's a strong relationship or a weak relationship, and meaning they tend to change together, while causation implies that one variable directly influences or causes change in the other. So ones we've done before, like the time you study and the score on your test, that is a direct causal impact on there. The more time you study, usually the better you do on your test. Okay, so here, um, precipitation in inches. This is deciding during the month of April. Alina keeps track of the number of inches of rains recorded for the day and the percentage of people who come to school with rain jackets. So you'll notice that the percentage precipitation in inches, as it gets 1.4 inches over here compared to 0 inches down here, the percentage of people goes up to around 90 to 100%. Okay, so remember these are decimals of your percentages. So this would be 10%, 20, 30, 40, etc. So close up to 100% of the people when it starts getting higher in rain. So now is this causal, a correlation, and or weak thing? So this would be a correlation. Yes, it does have a strong correlation, but it's not just that, it's also a causal relationship because as the rain increases, it's causing people to bring more jackets to school. So this is a causal relationship. It has a strong correlation, but it's also causal. Okay. A school book club has a list of 100 books for its members to read. They keep track of the number of pages in the books the members read from the list and the amount of time it took to read the book. After collecting data, they found their correlation coefficient to be a scatter plot was 0.93. So that is a very good correlation, a strong correlation. Not necessarily causal. Some people may read books faster than others. Some people may take a very long time to read just because of the way, not necessarily the number of pages, but just because they're slow readers. So there could be a case for causation, but not necessarily. I would say this is more like a strong relationship, but not necessarily causal relationship. So strong correlation. but we'll put a question mark on causal. Okay, so this one says the number of tickets left for holiday parties at a venue and the noise level at the party. So here, if they have very few tickets left, the decibel level is high. If they have more tickets left, the decibel level is lower. Okay, so again, does the number of tickets left over mean that the party is going to be quieter? So again, um, I'm not sure if you can see a direct relationship with that. It could be that there's music at the party, which makes it louder, not necessarily how many people and everything. So again, I would just say a strong relationship, but not necessarily causal. Okay. Without a visual scatter plot, would you think the amount of gas used on a trip and number of miles driven on the trip would be correlated or caused by one another? Well, in this case, the more miles you drive, the more gas you use. So this is definitely a cause relationship. So it's caused by one another. The more gas is used, the further miles you drive. Okay, so this is your stop and jot. You're going to put this on the door. You're going to put your answer on here. It says the relationship in the height and test scores graph appears to be strong. Does an increase in height cause an increase in test scores? Okay, so um, you want to state if you think this is causal, basically. It says, does an increase in height cause an increase in test scores? So are taller people smarter? Okay, and you can put here that if you think it's not causal or if it is causal, and then you're going to place this on the door whether you're confident in your answer, not sure, or you're confused about your answer. So there's going to be a place for all three of these for you to put it there on your way out. Okay, so let's look at your practice sheet today. Okay, so here it says many countries in the United States are governed by a city council. Many counties in the United States are governed by a county council. At public council meetings, county residents are usually allowed to bring up issues of concern. So this person brought up the fact that there's going to be 3 new frozen yogurt shops in the um, county, and they believe that it would create an increase in property crimes. They brought this data and scatterplot to show that in surrounding counties, the number of yogurt shops they have and the number of property crimes that are committed in those counties. And so they're looking at this um, graph here. So up here around 50, they have 20,800 property crimes. Down here, it's 15, that's around 20 something. That's a 22. Um, then you have 0, there's 600 property crimes. They have no um, frozen yogurt shops in their county. And so you can kind of see where the points are. And this is their equation that they did for the shops. So they're saying here the average, or with no shops, you would expect to have 1,496 property crimes. And then this is our relationship for every one shop open, 413.8, so 414 more crimes, property crimes are committed for every shop that's opened. Okay, so it shows a positive linear relationship between shops and crimes. According to these trends, counties with more of these programs tend to have more property crimes annually. Does the relationship between shops and crimes appear to be linear? Yes. If I had a problem. So yes, it does appear to be linear. Would you consider the relationship between shops and crimes to be strong, moderate, or weak? So if you look at this, it looks like a strong relationship. Got one that's kind of out here, a little bit away, but most of these are pretty close to the line, kind of linear. So I'm going to say kind of strong. Okay, so let's go over to the next page. Now it says using Desmos, the correlation coefficient of the line of best fit is 0.9661. Does the value of the correlation support your choice? Yes, because we said it was strong. We thought it was kind of, but this is actually a pretty strong 0.9661 is very strong linear because it's so close to 1. Okay, this is the equation, they said. Based on this line, what is the estimated number of additional property crimes for a county given that 3 more frozen yogurt shops than other counties? Okay, so if we put 3 in here is what it's asking for. So we're looking at 413.83 times 3 plus 1295.65. So this says, wow, oops, sorry, I missed a plus sign. So this says we can expect approximately 2,537.14 crimes in our area if we have more more crimes. So for every three shops, this is how much it should increase by. Okay, does the data support the claim that building 3 will necessarily cause an increase in property crimes? No, because there are other factors in play that could be causing property crimes. Maybe more people are moving into the area. Um, the maybe they don't have as a large enough police force. Okay, other things that you can put in there. Just think of it, but I don't think it's necessarily the cause of the increase in property crimes, because the building stores and stuff. Yes, it brings other people there, but it also brings more revenue and things, and so I think there's other things going on besides just frozen yogurt shops. Okay, last one. If the following 2 counties were added to the data set, would you still consider using a line to model the relationship? If so, how do you know a line is still the best model to use? If not, what other type of function might fit better? So what you're going to do here is you're going to take the values in the charts and you're going to put them into Desmos using these additional 2 counties um, along with the original ones from the table. Now, again, you want to look at the different types of possible equations. Okay, and just remember, if you're doing this on one table, you can do each one of these equations and look for this one. If you look at the r squared, since that's the only thing that's given on the other 2, just remember the r squared is just the r value squared. So it's the same thing. It's just a different piece of a statistic. It's chart. So you can look at the r squared values to see which one has the closer to 1 and which one would be your better value. Okay, so you guys will look at that later in class, but that's to finish your homework.